Hi everyone, this is the second lecture of Introduction to the Convolutional Neural Network and its practical problems. This is the second lecture of the first part, and the title is now The Most Famous Convolutional Neural Networks and Comparisons. Actually, the subtitle is a little bit deceptive because we will be talking about two architectures. However, we will be still asking questions to the convolutional neural networks. And actually, the first application of convolutional neural networks to the image classification goes to the MNIST dataset. The researcher was Jan LeCun, and I want you to see the application, see the first application of convolutional neural network. And you can see in this video young Jan LeCun and his lovely computer and showing the images to the camera and getting the right numbers with convolutional neural networks. The first convolutional neural networks model was named LeNet, and probably you will see it in this video. And in LeNet 1 you can use MNIST dataset, and you can apply number classification with that. After that, after 1993 until 2012, there are silent in convolutional networks for image classification. The problems were hardware problems, and you can understand it even in today because for large scale problems companies need very large companies need very expensive hardwares and very good hardwares to apply neural network problems to apply neural network to the problems, but the AlexNet was the igniter of using convolutional neural networks on image classification problem. AlexNet actually was the revolution because in 2012, at that stage in ImageNet classification challenge, there were no application of convolutional neural networks until that date, and the first time that convolutional neural network is used on was used on ImageNet challenge. There are the error rate was going to the very low stage, and you can see the architecture of AlexNet. And in the AlexNet there are very easy to read architecture. There are 8 layers, and there are some concepts of stride, max pooling, and also at the last stage you can see the fully connected layers, and also the other name is dense layers. And this is actually the easiest convolutional neural network model, especially while coding on Keras. You can code it very easily, and also in 2012 AlexNet has, or the convolutional neural network model that ranked first in ImageNet classification challenge, has 8 layers and accuracy of 0.5. Actually, this is this means 56% according to the 0 to 1 scaling. And now after that there are lots of architectures created by data scientists, and and also the team of from the team of Jan LeCun, from the team of Geoffrey Hinton, and one of them was ResNet 152. And you can ask that what is that number? Actually, 152 is the layer number of these convolutional neural networks, and also this CNN model gets complex and complex by the time. Actually, the time is about 3 years. The ResNet 152 is applied on 2015, if I'm correct. And you can see that VGG16, VGG19 model in here, and this is actually 1 or 2 years after AlexNet. The VGG19 was created, and after that, huge gap created by data scientists. Uh, this gap is on the layer number, and you can see the accuracy of 78% on ImageNet dataset. Actually, you can see the problem of layers in this image, and at the first year of AlexNet, at the 2012, you can see that AlexNet has 8 layers and error of 16.4. And then until the 2015, the layer numbers are not problematic. Actually, this is not a problem uh, for getting accuracy, but this is a problem of hardware. And 2015, you can see that ResNet model has 2152 layers, and but in the accuracy, the error rate was 3%. Actually, I don't want to go into details of architecture of ResNet. Actually, it's not that hard to apply ResNet for hardwares, and this is not this is actually complex model. ResNet is complex model. However, it's not problems. It's not a problem for hardwares, for GPUs. But the course is about this course is about applying and practicing convolutional neural networks, and the question is, do ImageNet results can be advisor for your smaller projects? Because in the ImageNet dataset, you can see 1000 classes. This means you have 1000 classes with millions of images. Actually, there are 14 million images in ImageNet challenge, and according to, if you try to look to the results of ImageNet and say that the best architecture is very good to apply projects of me, actually this could be deceptive, because you have small dataset and you have a small project, and applying these uh, solutions, applying ImageNet solutions to your projects is like using nuclear reactor to boil your egg. And the question to ask for this lecture: do ImageNet results can be advisor for your smaller dataset problems? Thanks for listening.